everybody, welcome to Danger Person Code. In this video, we're going to be looking at how to create the append, the prepend, and the print nodes method for a linked list, but in C++. So I've already done kind of the basic construction of the linked list in C++ in a previous video. If you remember, we created the class definition for just the nodes, and these are the kind of the base units of a linked list that hold each unit of data in the list. And then we created a basic class definition for the linked list itself, and we really just sort of stopped short at doing anything beyond the constructor. So we gave ourselves the option to construct a linked list that is empty, if we like, okay, by making the parameter empty true at instantiation, or to do it in the more traditional sense where you instantiate a linked list and you have at least, you have exactly one node in that new linked list with some value attached to it. Okay. So now what we're going to do is we're going to create an append, a prepend, and a print node method. So let's kind of just get into this, okay? So the constructor is its own method. It's a method that's called immediately at instantiation, okay? What we're going to do now is create a append method, and the append method is going to have a return value, a void. It's not going to return anything, it's just going to do something. So append, okay? And what append is going to do is it's going to add a node to the end of the list, right? If you've ever done this in Python, the logic, the general idea is pretty much the same. Append means add something to the end of a list, okay? And traditional list structures in Python actually have an append method that does exactly this. And we use the same language for adding a node to the end of a linked list, okay? So append is going to take exactly one argument, right, to fulfill a parameter, and that parameter is an integer that we're going to call value. So, like I said, nodes can carry all sorts of different types of data, but when you first learn how to just build structures like linked lists, the data is typically just something simple like an integer. Okay. So the very first thing that we're going to do in the append method is we're going to create a new node. Okay. No matter what use case we have for the append method, no matter what circumstances under which we're using it, we're simply making, this is the first thing that we're going to do is we're going to make a new node. We're always going to make a new node. So we're going to do it exactly the way we did it up here, okay, where we basically make the pointer that points to the new node at the same time that we make the node itself, passing value, right, passing the thing that gets passed to this parameter, right, to the instantiation of the node itself. So let's go back here, okay. So we're going to say shared pointer. It's important that we make shared pointers because there's going to be many instances in linked list operations where we need multiple pointers to point to the same exact memory location. Okay, we're going to give it a class of node since it's always going to be pointing to some sort of node object, and we're going to call it new node. Sorry. And they're going to make that equal to, again, go into our standard library, make shared. Okay, I'll type node. And then we're going to pass to this instantiation. And we are instantiating a node object here. I'm going to pass to this instantiation value. And then put a semicolon at the end so it doesn't get upset with us. So this value, this argument that gets passed to this parameter, right, is going to get passed then to this instantiation of node. Right? So we're going to create a node that has an integer value of whatever gets passed here when we call append. Okay. And then we just need to define a couple different use cases. So the first, maybe the most obvious kind of use case is just what if the linked list is empty, it has no nodes, and we're going to now append to it. Okay. So if this is the case, right, we need to check for it. So if what we're going to say is head equals null pointer, and we're simply checking to see if head equals nothing. If head equals nothing, remember head always points to the very first node. If head equals nothing, then there must not be any nodes. So this is one way in which we could check the the status of the linked list to see if it's empty. Another way we could check is just we could just say if length equals 0, right, which is dependent on whether or not length is being updated correctly, or if it's not, then this could create a bug. But if head equals nothing, then we know for sure it is an empty list. Okay, so if that is the case, if head equals nothing and the linked list is empty, we're going to do basically what we did here. Here. We're going to take head and we're going to make it equal to new node, and then we're going to take tail and make it equal to head, so they're basically pointing at the same node now. So there's only one of them. And then we're going to update length, but further down in the method. Okay, so we're going to say head is equal to new node, and then tail is equal to head. Right? And then we can move on. That is literally it if the linked list is empty. And then we can just say else if the linked list is not empty. We don't need any other more specific condition. If the linked list is not empty, if there is any number of nodes, 1, 200, 10,000, it doesn't matter, the logic is going to be the same. What we can then say is that tail next. And if you're unfamiliar with this arrow notation, what this basically means is that we're trying to access a property or an attribute on a class object that the pointer right here is pointing to. There is no next on tail. Tail has no attribute next. Right? Tail is a pointer. It's a shared pointer. But it's pointing to a node, and if you go up here, remember, it's pointing to a node that has a next property, which is also a pointer, by the way. Right? But this allows us, right, to form connections between nodes. Yeah? Okay. So what we're going to say is that tail.next, or tail arrow next, right, would be a dot notation in Python. Tail arrow next, okay, it's going to equal new node. And what that simply means is the node that tail is pointing to, its next pointer, its quote-unquote next pointer, will now be pointing to new node. So a connection has now been made between the node that tail is pointing to and the node that new node is pointing to. Okay, if that makes sense. I know this can get a little confusing in C++. It's much more straightforward in Python, but the logic is pretty much exactly the same. So even though these memory locations are scattered all over your computer, the way this is usually conceptualized is that all the nodes are kind of like lined up in a nice neat little row from left to right, and this new node just got added to the right of the node that used to be tail. All right, it still is tail, but we're gonna change that in a second. Okay, so tail is always pointing to the end node, and it's not now. It's pointing to the second to last node because we just added a new node. So we simply have to update tail and say that tail is now equal to new node. Okay, so we just added a new node to the other side, immediately adjacent to tail. And then we moved the pointer that was pointing to tail, or the tail node, right, to the new node. And now tail is pointing to the appropriate place. And whichever of these use cases gets triggered, doesn't really matter. Length is always going to be iterated forward by 1. Okay, and there's your append. There it is right there. All right. So let's try prepend. You'll find that prepend is basically the same logic, just it's slightly in reverse. So prepend means that we're going to add a node to the beginning of the linked list. So if you think about this conceptually, to the left of head. Okay. So head is going to have to be readjusted instead of tail. So we're going to have, again, a return type of void. It's not going to return anything. It's just going to do something. Prepend, same parameter value. We're going to create a node here, and then we're going to assign it someplace in the linked list. Okay. So the very first thing we are going to do is we are going to create a new node exactly the same way that we did before. Okay. Exact same concept. We created a pointer that points to the node, right, at the same time that we instantiated a new node with the value that got passed to this. Okay. Nothing different about that. The only thing that's different is where we're going to put it. In the same way, we're going to check if head equals null pointer. Okay. Then head equals new node. Tail equals head. Okay. Also exactly the same as the last method. Now, here's where we have a difference. Okay. So the first thing we're going to do is we are going to take new node dot next, or arrow next, and we're going to make it equal or set it equal to head. What we've just done is we've just made the next most adjacent node to new node head, right? It used to be connected to nothing. New node used to be connected to nothing as its next, right, property or pointer. Now it's connected to head. Okay, so we've placed new node basically to the quote-unquote left of head, and now we just have to reassign head just like we did with tail. So head now equals new node, because new node is now the very first node. Okay, and in the same way, go down here, length will be incremented by 1, regardless of which of these gets triggered, whether the length starts out at 0 or the length starts out as whatever, 5, 10, 500, 10,000, it's going to get incremented by 1 because we're adding a new node. Okay. So one more method now. Okay. I'm going to add one more method here, and again, this is going to have a void return type, and I'm going to call it print nodes. It's not going to take any arguments to satisfy any parameters. It's simply going to iterate through the linked list. It's going to print each node to the console, and it's going to do that until it basically runs off the edge of the linked list. Okay, so what I'm going to do first is I'm going to make a smart pointer, which is again a shared pointer, and I'm going to call it temp, and I'm going to initially set it to be equal to head. So it's going to be pointing at the same exact space that that head is pointed to. It's going to start off at the quote-unquote first node. Okay, and then I'm going to create a while loop. The while loop is going to run so long as temp does not equal null pointer. Now what this means is that with each round of the while loop, it's going to check and see if temp equals something as opposed to nothing. When it equals nothing, it means that it is essentially run off the end of the linked list. Right? It's moved on to a next place that is equal to null pointer. Right? So we're going to iterate through each node, first node, second node, third node, fourth node, until it basically just runs off the end, runs out of nodes, and equals nothing. And at that point, we know, okay, we've iterated through all the nodes, and we're done. So long as this is the case, we're going to print out, first we're going to print out the value. Okay, so we're going to say cout. We're going to create a cout statement. Okay, and we're going to print temp. So you don't make this mistake. Don't print the pointer, right? Or the node, right? Sometimes when you do this in Python, sometimes you'll print out the node and you'll get this like big crazy memory location, just kind of print it to the console. We want the value. So remember how we access a property or an attribute of a node that a pointer is pointing to. We use this arrow notation. So temp value, because we know that each node has this property value, right? Okay. Okay. So we're going to print that out, and the next thing we're going to do is we're going to iterate temp forward. So what we're going to say is that temp equals temp next. Okay, temp is going to become equal to whatever the next attribute of the node it's pointing to equals whatever the next most adjacent node is. It's going to be reassigned to that. That's how it will iterate. This is how we do this. This is how we iterate things along a linked list. We simply make that thing equal to the next attribute of the node that it's pointing to. Okay? And then that's it. That is basically print node. So this is the class definition that we have right now. Okay? It ends right down here. So we can create a whole new function here. So int main to test it. So what we'll do first is we will instantiate our linked list into an object. So it's of linked list type, obviously. We'll call it LL. All right. And we'll set that equal to an instantiation of linked list. And I'm going to make it empty. So remember when we wrote this class definition, we said, okay, well, if this is true, if empty is true, then all of this becomes true, right? And it's basically empty. Length is 0, head and tail equal nothing. Okay, so we're going to make that true. Okay? And semicolon, so it stops yelling at us. Okay, so we have this instantiated linked list. Now we can start to call methods on it. We can call append several times, and we can add things into it. So let's say append 34 to the linked list, and then we're going to append 7 to the linked list, and then we will append 25. Nope. Append 25 to the linked list. Okay. Now let's call prepend. Prepend 3 and prepend 10. Okay. Now let's call one more method and let that be print nodes. Okay. So look what we did here. We started out with an empty list. We added 34, 7, and 25 to the end of it, right? So at this point, it's just from left to right. It should read 34, 7, 25. But then what we did was we added 3 and 10 to the beginning. So we added 3 to the beginning, then we added 10 to the beginning, right? So it should read, when we print it out, should read 10, 3, 34, 7, 25. Let's test this and see if it actually works. So let's save everything. Okay. And then we will go and we will compile this. So I'll show you how to do this. So if you go here, if you go to the location of something in Windows anyway, of something in your hard drive, and you just write CMD, right, and then you hit enter. It'll open up a terminal with that exact location. It's pretty convenient. So we use our compiler here. G++ is the typical C++ compiler. Recommend getting it installed on your computer if you haven't already. And we can just write the name of the file, testlab.cpp, CPP for short for C++, C++, and then we can add a tag here so we can call it whatever we want. We'll just call it testlab, right? Okay. So this should compile if we did everything correctly. So let's hit enter here, and there you go. It has no errors, means it's compiled. So we just have to write testlab now, and it should print out everything in the order that we. And there you go. 10, 3, 34, 7, 25. Just like I said, 10, 3, 34, 7, 25. Go back. Okay. So you can see that we did our work correctly here. Okay. Everything worked out pretty much exactly as we expected it to. And that is essentially how to write the append, the prepend, okay, and the print nodes methods for a linked list in C++. Thanks for watching, everybody. I hope you found this helpful. I hope it made sense. Like, subscribe, and stay tuned for more C++, and stay tuned for more savage, brutal code.